All right, we're going to discuss even and odd rational functions. Today we're only going to do polynomials. We're going to discuss these algebraically and graphically. I know your homework does it graphically first, but we're going to do algebraically. So a function is an even function if whenever in your f of x, wherever an x is, you insert negative x, you get the same answer for all x in the domain. A function is an odd function if whenever you insert the negative x in for the f of x, you get the opposite as the answer for all x in the domain. A function is classified as neither if neither situation is true. We're going to do some of these examples and try to come to a cogent, that means convincing, conclusions about some of the patterns. So starting with our first example, I'm going to take the x that's black and make it a parenthesis and insert the negative x. When I square a negative x, I just get an x squared. Notice the red matches the black. They're exactly equal, so f of negative x equals f of x. And so this is an even function. Now let's go to the next one. Wherever I see the x, I'm going to put a parenthesis and a negative x instead. The x, a parenthesis, and a negative x. When I take the negative x and cube it, I get negative times x cubed. When I multiply these two together, I get a positive 3x squared. This product yields negative 2x. Now notice if I look carefully, these have opposite signs. So I can factor out the negative. And now it looks like the original. So f of negative x is the opposite of f of x. And so this is an odd function. Another example. When I do this one, again, I'm going to play the insert game. So instead of x, it's negative x quantity to the 6th, negative x quantity to the 4th, negative x quantity to the 2nd. A negative to the 6th just gives me x to the 6th. A negative to the 4th just gives me the 4th power, and a negative does not change the signs. So the red matches the black. And so f of negative x equals f of x. And so we have an even function. Another example. Again, I'm going to insert. Instead of x to the 7th, it's the quantity negative x to the 7th. Instead of x to the 5th, it's the quantity negative x to the 5th. Instead of x to the 3rd, it's the quantity negative x to the 3rd. Instead of x, it's negative x. A negative x, when I 7th power it, gives me negative times x to the 7th, times the original negative gives me x to the 7th. Negative x to the 5th gives me negative times x to the 5th, times 8 is negative x to the 5th. Negative x to the cubed gives me negative times x to the cubed, times the negative is positive x cubed, and the last product is just negative 6x. I notice that the red and the black are exact opposites, so I can factor out a negative. And when I factor out the negative, just change it, change it, change it, change it. And now the black matches the purple. And so f of negative x is equal to negative f of x. And so we have an odd function. Let's go to the next one. I'm going to insert the negative x. And I get negative times x cubed, which is negative 10x. This gives me positive x squared, which is negative 4x squared. That product's negative 3x, that's negative 8. I notice they're not exactly the same signs, and when I negate, I don't get exactly the same thing either, so this is classified as neither. Example 6. I come down to example 6, I insert the negative. And I get negative x to the 7th, product 7x to the 7th, insert negative x cubed times negative, positive x cubed, and the product. I see that the red and the black are opposites, so I negate, and I change the signs. Now the purple and the black match. So g of negative, that's just to go up. G of negative x, that's supposed to say g, folks. The teacher is having some issues. I don't know if I can get my pen open because I was trying to be careful, but I screwed up on these. So g of negative x is g of x, therefore odd. I come over to this one, and while I am here, I'm going to see I have an h. I insert. I get a negative x cubed. That's a positive x squared times the negative. I see that it doesn't match f of x. That's supposed to say h of x. It doesn't match h of x. And when I change the signs, it doesn't match negative h of x. So my conclusion is that it's going to be neither. When I come to my next one, I'm going to insert. Negative x to the 8th is x to the 8th. Negative x to the 4th is x to the 4th. Negative x squared is x squared. Things stay the same. So k of negative x equals k of x, and it's an even function. Now, before we broach the pattern, I want you to remember that 7x to the 0 is the same as 7 is the same as 7x to the 0, and negative 2 is the same as negative 2 times x to the 0. Now we're going to group evens with evens, odds with odds, and neither as its own group, and we're going to draw some conclusions. But we're moving to the next room to do this. All right. Okay. So notice I've got all my evens here together. I put on x to the 0, and I want you to look closely at every exponent. In the first one, 2 and 0. In number 3, 6, 4, 2, 0. In number 8, 8, 4, 2, 0. We see that all exponents, including the constant one, which is really a 0 power, are even. Let's look at the odd ones. Now, I've put the ones on so we can see it. But in number 2, the exponents are 3 and 1. In number 4, 7, 5, 3 and 1. In number 6, 7, 3 and 1. And all the exponents are odd, and there's no constant term whose exponent would have been 0 anyway. Look at my neither ones. 3, 2, 1, 0. Well, I've got some odd and some even. 3, 2, 0. Some odd and some even. So when they're mixed, we're not going to have even or odd, but neither. So the definition for rationals, this is the definition we use for rationals, but polynomials are a subset. And for tomorrow's worksheet, we're going to talk about rational expressions, but now let's get on to talking about graphing. When we have even functions and we're going to graph, they're going to be symmetric with respect to the y-axis. Now, what does this mean? This means the right side reflects onto the left side and vice versa. Think of the y-axis as your mirror, and we're going to do a mirror image. And a perfect example of this is the parabolas that we've been doing as long as they're on the y-axis. Odd functions are symmetric to the origin. This means that you reflect across the x and the y, both a double flip. This means that both the x and y coordinates and the negations of these coordinates are on the graph. What that means is that if I have, for example, 2, 3, then I also have negative 2, negative 3. These graphs always go through the origin, and I want you to think of y equals x cubed and y equals negative x cubed. If neither situation occurs, yep, it's going to be neither. Now, we're going to look at my computer screen to do the rest of the examples, and this is nuts, but folks, I, like you, have issues at home. See, now here's the parabola I was having you think about. See the mirror reflection, it's on the y-axis, that's an even function. Here's your cubic. It's an odd function because like 1, 1 would be negative 1 down here. When I look at this one, it's going to be considered neither because the y-axis is where we're supposed to have our vertex, or it's supposed to reflect. On this one, what do I see? Negative, negative turns into positive, positive, so it's going to be an odd function. What about this one? Don't you see how that y-axis is just a mirror reflection? So it's even. What's wrong with this line? It's not reflecting, and the positives don't turn to negatives. It's a jumbo. So it's going to be neither. Notice the right side and the left side are the same, so it's even. And when I look at this graph, what's happening here when I see this picture is that it's going to be, if I could draw my line, we're going to see it's going to reflect across the origin. Now I'm going to get some more pictures. So here, do you see how it's a mirror reflection, even? Again, minus plus becomes plus minus. Over here, minus, so it's odd, minus minus, plus plus, it's odd. Another example of even, a perfect reflection like a parabola reflects. So this is even. And then this one, what happens? The negative positive becomes positive negative. It's your cubic, so it's odd. So let's do one more set. When I look at this function, what do I see? This plus plus becomes minus minus. I can see how if I flip it and flip it, I'm over there. Down here is another example of an odd function, because the top to top, the top, they're opposites, minus minus, plus plus. But you can see that if I just flip it and turn it, or twist it across the x and the y, and notice it goes through the origin, goes through the origin. It must go through the origin to be odd. This next one, these two are even. Why? Just look at the perfect mirror images. Look at the perfect mirror images. These functions are neither, because I needed it to have the y-axis for the reflection, and this one needed to go through the origin. It's not going through the origin, so it's neither. So now you're ready to do worksheet 1, front and back.